In this video, we'll discuss how to find the domain of an equation. Okay, so let's start with a very simple example. So our first example, example A, will be 9x minus 3 equals 15. Okay, so when we're talking about finding the domain of a function, or sorry, of an equation, what we're saying is we want to know what values can I plug into x, or what values can I plug into the variable and get real numbers on both sides of the equation. Okay, so domain, it's not asking us to solve for x, right? There's an answer for x in this equation. Like we could solve and find what x equals, right? We'd add 3 to both sides. Then we would divide both sides of the equation by 9, and we would have an answer for what x is. But that's not what this question is asking. They're not asking us to solve for x. They're asking us to find the domain, which means to find all the values that I'm able to plug in for x and get a real number on both sides of the equation. Okay, so for the left-hand side of the equation, if I were to plug in any value for x, right, any value times 9 minus 3, as long as it's a real number, I will get a real number out, right? So if I plug in 2, 3, 4, it doesn't matter. If I plug in a real number for x, I'll get a real number out of this equation. Then on the right-hand side, I don't have to worry about it because it's a real number over there already. So my answer for what the domain is any real number from negative infinity to infinity. Okay, and then if I were to write that domain graphically, I would draw a number line and then shade in the entire number line. Any number. Okay, so let's go on and do a more difficult question. So this will be example B. And so let's say we have y divided by 2 equals 1 minus the square root of y plus 3. Okay, so in this one, let's start on the right-hand side, okay, and we have y divided by 2. Now, any number divided by 2 is a number. Any real number divided by 2 is a real number. So in this one, on the left-hand side, I don't have to worry about it. Any real number, I'll get a real number out. Now, on the right-hand side, I do have a little bit more of a concern in that I have this square root sign. So remember that inside of a square root, you can't have a negative number, right? Square root of negative 1 is a non-real number, okay? So square roots, inside the square roots must be positive. So y plus 3 must be a positive number. It must be greater than or equal to 0, right? Now, square root of 0 is 0, so it's allowed to equal 0. So it has to be 0 or a positive number. So let's subtract 3 from both sides to solve this inequality. I get y is greater than or equal to negative 3. All right. So now that's going to be my domain. As long as y is greater than negative 3, I will have a positive, or I will have a real number on the right-hand side and a real number on the left-hand side. So as long as y is greater than negative 3, we have a number that's in the domain. So I go from negative 3 to infinity. Okay, that's my domain. Or if I were to do this graphically, here's 0, 1, 2, 3. Here's negative 3. And then, oops, I noticed that I made a mistake here. This should be a bracket, not a parentheses. Why is that? It's because negative 3 is included, okay? Remember, parentheses means strictly greater than negative 3, or we're getting infinitely close to negative 3, but we don't include negative 3. But if I have the bracket, the hard bracket, that means negative 3 is included. Okay, and then here in my number graph, my number line graph, I would have a solid circle on negative 3 because negative 3 is included because of that equal sign. If it was not included, it would be an open circle. Okay, and then I just shade over to the right, greater than or equal to negative 3, and that's my solution. Okay, one more example. example C. So in this case, we have the square root of 5 minus x divided by x minus 6 equals 3 over x. Okay, so starting on the left-hand side, I know that the square root of 5 minus x, I need to be concerned. I need to say that the inside of that 5 minus x must be greater than or equal to 0. The inside of the square root must be greater than or equal to 0, just like in the previous example. Now I also have this x minus 6 on the bottom of a fraction. Now remember, on the bottom of a fraction, if you put 0, any number divided by 0, that's an undefined number. Okay, so it's not a real number. So I have to be concerned about that. I need to say, oh, x minus 6 cannot equal 0. If it does, then I get a non-real number on the left-hand side. Now, if I go over here to the right-hand side, I also have an x on the bottom of the fraction. So I also know that x cannot equal 0. Remember, when you're finding the domain, you have to look on both sides of the equation. Okay, so let's go ahead and solve this. I'm going to add x to both sides of the equation here. And I get 5 is greater than or equal to x. Or in other words, x is less than or equal to 5. Okay, I'm going to add 6 to both sides of this equation. So I get x does not equal 6. And then here we have x does not equal 0. So there's 3 pieces that I need to be concerned about. Now when you start getting more pieces like this, sometimes it's easier to start with graphing your domain and then come up with the interval notation. Okay, so I have here 0, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, and here's 6, and here's 7. Okay, so at 5, I have a solid circle. Okay, because we can equal 5, right? But x must be less than or equal to 5. Okay, at 6, I have an open circle because I can't equal 6. And at 0, I have an open circle because I can't equal 0. Alright, so I know that x must be less than or equal to 5. So that means I'm going to start drawing my graph. I'm going to start shading in the less than direction. I'm going to skip over 0, and then I'm going to go onward. Okay, so the fact that x can't equal 6 is already taken care of with the fact that x must be less than or equal to 5. So I don't really have to worry about the fact that x can't equal 6. Okay, so now when I'm writing it in interval notation, I'm going to start at negative infinity, and I go all the way to 0, okay? And I don't include 0, so I have the soft parentheses. And then I'm going to union, right, that along with 0 all the way till we get to 5. And then I'm going to include 5. Okay, and then there we go. That's my domain.